GM everyone! My name is Milica and I'm Developer Relations Engineer at zkVerify and PhD candidate in zk. Today we're going to dive deeper into verifiers and explain how do we actually verify our proofs. Imagine you're a developer and you want to verify a zero-knowledge proof on-chain. You're looking for ways to do it and decide to verify it with zkVerify. Let's walk through it. Let's start with our users. So let's say we have and user zkapp and we have zkVerify. So how does this interaction look like? So end user will interact with the zkapp. Let's say casts a vote if it's a voting application. And zkapp will generate a proof. So this one will have vk or a hash of it, public inputs, and we'll have a proof. So what happens next is submitting proof to zkVerify, where we will have vk or hash of it. It can be pre-registered and then you will have much less cost. It will send also proof and public inputs. So what happens next is that upon submitting proof to zkVerify, zkVerify will answer with attestation ID. That indicates the batch where the proof will be included. Next, what happens is that the zkVerify is computing the Merkle tree. So let's write that down. Okay, and this says receives proof. We can compute a Merkle tree from multiple proofs. So this is the case. Tree build. Next thing that happens is that upon Merkle tree computation, when the attestation happens, we will have new attestation. If everything is well, of course, we will have event called new attestation. So that happens when the block finalizes. New attestation. So of course, once the block finalizes. And this happens from proof of existence palette. This is the palette that actually is generating this event. How does it look like? Let's say at station something is finalized with Merkle root 𝗏, for example. This event is sent through zkVerify back to the zkapp. This is the result. It goes together with attestation ID and Merkle root. From here, zkapp can send verification result and attestation ID back to the user. We'll have, of course, there is something called dev user that can ask zkVerify to register verification key. This is done due to the costs. It's much less costly to register verification key in advance and just submit hash every time you're supposed to submit verification key than to submit your verification key every time. So what zkVerify does is computes the hash and sends it back to the dev user. Now that we have all of this, the zkapp can with attestation ID and leaf digest, which is also another name for a statement hash, can do the following query through the RPC of zkVerify. ZK app can query for a couple of things. For this, we need leaf digest and attestation ID. And we query RPC from zkVerify, and we're going to receive a couple of things. One thing is Merkle path to the leaf index, and the number of leaves in the tree. And with that, we can query attestation and see if our proof is actually included on chain. And yeah, so there are like a couple of things I want to say here as well. So things that we have here, like attestation ID that's being sent. So attestation ID identifies the batch. So what kind of batch is that? That is the batch where the proof is included. Also some other things like Merkle root proves all included proofs. And we have leaf digest or statement hash. It identifies your proof. And we'll have Merkle path. It will allow the reconstruction of the root from the leaf. And we'll have a leaf index and count. And it will prove the position in the tree, the correct one. And that's it. If you have a ZK app or a project of your own and you want to verify zero-knowledge proofs, we currently support 6 proof types: cross-fixing, 𝗓𝗏, RISC-0, NOIR, ultra-PLONK, space and time proof of SQL, and zkSync error. I would strongly encourage you to follow us on Twitter, join us on Discord, and we're here to support you. And currently we're working on our mainnet, so stay tuned.